Okay. All right, I'm waiting. I need all those Chromebooks closed. Closed up completely. Close those up. Okay, so yesterday we looked at solving absolute value equations where we were able to isolate an absolute value on one side and then we had a number on the other side, right? Remember that? Okay, and we did, went real well. We decided that all we had to do was, there were three parts to that. We isolate the absolute value, then we split the absolute value equation into two regular equations, and then we just solved those. There really were three parts to that process. I'll tell you what, let's warm up with just a real simple one here. How about if we have something like this? What do we do first? How come? What are we trying to do? Isolate the absolute value. So that's part one. All right, so we subtract 3 from both sides. Those guys cancel. That gives me 2 times my absolute value equals 8. What's next? Divide by 2, because I got to get rid of that 2. Good. So those guys canceled. And then I got my isolated absolute value. Equals 4. Okay, so that's part one. We did it. We isolated the absolute value. What was part two? Okay, good. We split it into two regular equations. Remember why we're doing that? Because we can't touch anything inside the absolute values. The algebra gets real complex and we don't want to do that. So we're going to split this into two regular equations so we can do normal, simple algebra. What's my first equation? X minus 1 equals 4. Yeah. What's inside the absolute values equals the positive outside number. Or, what's my second equation? Yeah. What's inside the absolute values, x minus 1, equals the negative outside number. That was part two. We split it. And then finally part 3, solve them. Easy. Well, that part's easy. What do I do to isolate x? Add 1. Okay, so we get one of our solutions is x equals 5. Our other one, what's negative 4 plus 1? Good. And we get two valid solutions that are, if we plug them in, they're going to work. Guaranteed. Okay? All right, what's different today? Well, today we're going to look at situations like that. What if I've got variables on both sides of the equation? Now we're going to look at two cases. The first one is, what if I have an expression inside absolute value bars on the left side of the equation and another expression inside absolute value bars on the right side? Okay, I want you to look at some patterns here first. Would everybody agree that positive 2 or the absolute value of positive 2 equals the absolute value of positive 2? True. Would everybody agree that the absolute value of negative 2 equals the absolute value of negative 2? Okay. Absolute, true or false? Thumbs up or down. The absolute value of negative 2 equals the absolute value of positive 2. True, right? How come? Because the absolute value bars are going to make them both positive no matter what, right? And then I could flip those around and the absolute value of 2 would also be equal to the absolute value of negative 2. Okay, so what happened there? Well, one of two things really happened. Either I had the same number inside the absolute value bars on both sides, in which case what's inside the left equaled what's inside the right, or they were opposites. What was inside the absolute value bars on one side was equal to the opposite, the negative, of what was inside the absolute value bars on the other side. Agreed? Okay? The first two cases, they were the same on both sides. The last two cases, the numbers inside were actually opposites, but the absolute value bars protected them and made them all positive, right? Okay, so then when I'm splitting this, what does that mean? How is this going to split into two separate equations? What do you think? Okay, so we're really going to follow the same rules we did yesterday. What's inside the first set of absolute value bars, which is 3x plus 2, is either going to equal the positive of what's inside the second set of absolute value bars, or it's going to equal the negative, the opposite of what's inside the second set of absolute values, right? Same rules. There it is, right? 3x plus 2 either equals 5x minus 8 or negative 5x plus 8, right? And then I just solve those. No big deal. And that part's easy. That's not a big deal, right? If we solve those, over here I could just push the x's to one side. They did it different than we would. We'd probably push the x's to the right. They pushed them to the left. Subtracted 5x from both sides. They subtracted 2 from both sides, divided by negative 2. And one of their solutions was x equals 5. Okay? Over here, added 5x to both sides, subtracted 2 from both sides. You got 8x equals 6. Divide by 8. I got x equals 6 over 8, which is the same as 3/4. Okay? Let's just show that those work real quick. Here, I'll tell you what, let's make that one blue. Let's just show that those work. Here's my original equation. Let's use technology to do it. How about that? Yeah, let's use technology. Remind me how to do that. How could I use technology to check the green solution? Desmos. Okay. So you got to really watch this closely because I'm going to show you something really interesting that's going to help you understand today, but you got to focus. You got to focus. So remind me how to do that again. F of x, I said f of x equal to the expression on the left side. So what is that? 3x plus 2? Absolute value of 3x plus 2. Absolute value of 3x plus 2. Okay. How about the right side? What do I do? G of x. What's the right side? Absolute value of 5x minus 8. Okay, so let's check our solutions. How do I check 5? Okay, so I'm going to do f of 5 gives me 17. G of 5 gives me 17. Did it work? Yeah, okay. What about my other case was 3/4? Okay, let's try that one. F of 3/4 gives me 4.25. G of 3/4 gives me 4.25. Okay. Now let's try something here. Everybody see that? So it worked. Both of them worked. Okay, what would have happened if I wouldn't have had the absolute value bars on the right side? So if it was just plain old 5x minus 8, well, 5 would have worked. When I plug 5 in, I would have gotten positive 17 on both sides, but look what would have happened down here. When I plug in 3/4, I would have gotten a negative answer on the right side. Okay? That wouldn't have worked, would it? If there weren't absolute value bars protecting the right side, I would have had a negative number there, and that would have been a problem because I would have had an absolute value on the left side equal to a negative number on the right side. Is that possible? No. Okay, so that solution would not have worked, but the absolute value bars on the right side saved the day because they made that negative outcome turn positive, and so it worked. Everybody see that? Okay, so as long as you have absolute value bars on both sides, protecting both sides, your solutions are always going to work because it's impossible to get an output of an absolute value that's negative. Both sides are going to be made to be positive by the absolute value bars. So they're saving the day there. Everybody get that? Okay. All right, why don't you guys go try one of these? Go try that one. Okay, real quick here. So from yesterday, what was our pattern? What did we do yesterday? If we had an isolated absolute value equal to a number, what were our two equations that we got? Either what was inside equals, so U, that just represents all the stuff inside, equals positive A, because A is the number on the other side, or U equals negative A. And we're just following the same pattern again, aren't we? So like in one like this, we're going to split this and we're going to say what's inside the first absolute value, which is x minus 3, either equals what's inside the second or negative what's inside the second, the opposite of what's inside the second. So that's what we get, right? X minus 3 either equals that or negative that whole thing. And then I would just solve those. So what do I get over here? Well, I'm just going to add x to both sides to cancel that x. So I get 2x on the left. I add 3 to both sides. I get 2x equals 8. So I get one solution is x equals 4. What about over here? If I distribute the negative, don't I just get that? If I subtract x from both sides, well, look what happens. The x's go away, right? And if the x's go away, then I'm left with no x's, but I have the equation negative 3 equals negative 5. Is that true or false? Okay, so what are the math gods telling us? If the variables disappear and I'm left with a false statement, no solution. Okay, so this one over here, so I get no solution from my second equation. So show me with your fingers, how many solutions total did I end up getting? Just one. Only got a solution from the first of my two equations, right? Okay, so now let's look at the other possibility. What's different about this kind of a problem? What do you see that's different here compared to the last couple examples we looked at? Yeah, okay. The right side is not protected by absolute value bars, right? Okay, do you see potentially a problem there? Look ahead here, be a chess player. Look ahead and see if you can anticipate some things about this. When I split this into two equations and solve, it's possible I might get solutions, I might get values of x that when I plug them in, make that right side negative. Is that going to work? No, because I have an absolute value on the left side, so an absolute value can only equal numbers that are what? Positive or 0, but never negative. So do you see a problem here? So there's a possibility now, because the right side is not protected by absolute value bars, that we might get some values of x that don't work for our solutions. Give me thumbs on that. Does everybody see that? Okay, so what am I going to do? I'm going to follow the same pattern. So I've got an isolated absolute value already. Here it is. I have the absolute value of x minus 4 equals, that's what's on the right side. So what would my two equations be that I split this into? So x minus 4, I'll get you started. X minus 4 equals what? Okay, well, do the easy one first. X minus 4 equals that, positive whatever's on the right side. Okay, x minus 4 equals 5x plus 12, or what's the second equation going to be? Negative the whole thing, right? Negative the right side. And now I just have to solve those. Okay, let's solve the left one. What would I do? Where am I going to push the x's? To the right, I agree. Okay, so we'll subtract x from both sides to cancel the x's. If the variables are going to the right, numbers go left. So we'll subtract 12. And we get negative 16 equals 5x minus x is 4x. So what's my solution then? What am I going to do next? Divide by 4. And so I get the answer x equals negative 4, right? There's one possible solution that we'll have to check. How about this one? What would I do? Distribute. Okay. So let's distribute. And I get x minus 4 equals negative 5x minus 12. Agreed? Okay. Where am I pushing the x's? To the left. Okay. I agree. We're going to add 5x to both sides. Cancel those. If the variables are going left, the numbers go right by doing what? Adding 4. Good. Okay, and that's going to give me, if I add those up, I'm going to get x plus 5x is 6x. Negative 12 plus 4 is negative 8. Last step, divide by 6. Okay, so those guys cancel, and I got my other solution. My other solution is x equals negative 8/6, which reduces to negative 4/3. Now we want to check these, right? And we'll check these with Desmos. So f of x equals the left side, which is the absolute value of x minus 4. What does g of x equal? 5x plus 12 in the original equation, right? Okay, so g of x equals 5x plus 12. Well, let's try both of these. If I plug in negative 4/3 into f and g, I get positive 16/3 on both sides. So does it work? Yes, it works, right? Those are the same. Look at that. Okay, these two are equal, so it checks out. That solution worked. Okay. Let's check the other one, negative 4. If I plug negative 4 into f of x, which is the left side, I get positive 8. If I plug negative 4 into the right side, I get negative 8, which we can see pretty easily, right? If I plug in negative 8 or negative 4 for x, what's 5 times negative 4? Negative 20 plus 12. Negative 20 plus 12. Negative 8. Okay, alarm bells should be going off in your brain. What's wrong with that? I can't be negative. I can't have the output of an absolute value equal a negative number. So that means that that solution x minus 4 is extraneous. What does that mean in math, do you suppose? It doesn't. It's false. It doesn't work. It's a solution. They tried to trick us. Those wily math gods. They tried to trick us. It's a false solution. So what do we do with it? We cross it out. It's not, that one doesn't work. That's not a valid solution. So how many valid solutions did we get? Just one. So what's the moral of the story here? This is a real, when you're doing these problems, what's your strategy going to be? Okay, always check your solutions in what case? Okay, but I mean, in what case? Like, okay, if you have variables on the other side of the equation, right, the right side, we'll say the absolute values on the left. If you have variables outside of absolute value bars that are not protected by absolute values, you have to check your solutions because they might be extraneous. They might be asking you to have an output of an absolute value be negative, which can't happen. Everybody get that? Okay, but in this case, we didn't really have to check anything. I mean, it's a good idea, but we didn't have to check anything. Why? In this case, there cannot be extraneous solutions. How come? Because both sides are protected by absolute value bars. Both sides are going to be positive no matter what. There's no circumstance here where we would have to say something like the output of an absolute value is negative because the right side can't be negative. It's protected by absolute value bars. Okay, give me 1 to 5 on that. You see how that works? Isn't that kind of cool? Okay, that's a way to conceptualize that and think about it. Okay, to play it safe, what could you always do? Just if you forget that, what could you always do to play it safe on a test? Check your solutions, right? You could always just check them, right? But you really, technically, you really only have to check them here because when one side has variables that are not protected by an absolute value bar, then some solutions might actually be false solutions. Okay? Go to work. Assignment's up there.